Good afternoon. Now I want to explain about the valence electron pair repulsion theory. What is meant by valence electron pair theory? In the chemical bonding, this is one of the important chapter to discuss about the geometry or structure of the molecule. What is valence electron pair repulsion theory? Now I want to explain. Z is equal to, this is important formula, 1 by 2 into number of valence electron on central atom plus negative charge, how much it is negative charge on the molecule, plus minus it is positive charge plus total number of monovalent atoms around the surround the central atom. This is the formula of to calculate the hybridization of any molecule. This is equal 1 by 2. Z is equal to 1 by 2 into number of valence electron on central atom plus negative charge on the molecule minus plus positive charge plus total number of monovalent atoms surrounding the central atom. What is monovalent atoms? Hydrogen, fluorine, chlorine, bromine, iodine, etc. are considered as a monovalent atoms. This is the valential electron pair theory, one of the formula. Based on that, we have to calculate different molecules, their hybridization, how many lone pairs are exist in the molecule. First of all, we have to take one of the molecule is methane. Next, we have to take ammonia. Next, we have to take water molecule. According to hybridization, if calculate this, Z is equal to 1 by 2 into this is its number of valence electron on central atom. This is carbon is central atom. How many valence electrons are there? This is fourth group element. That's why this is space 4. Negative charge is 0. Positive charge is not there. 0. Number of monovalent hydrogen is the monovalent atoms. Total around the carbon number of monovalent atoms is 4. 8 by 2. This is equal to 4. Z is equal to 4 means sp3 hybridization. If you want to calculate the ammonia, in this case Z is equal to 1 by 2 into nitrogen is the fifth group element. It is number of valence electron on nitrogen is 5. 5 plus negative charge is not there, positive charge is also not there. Total number of monovalent atoms is 3 plus 3. 5 plus 3, 8. 8 by 2. This is equal to also 4. This is also sp3 hybridization. If you want to calculate in the case of water molecule, Z is equal to 1 by 2 into oxygen is the central atom. Central atom, this is oxygen is a sixth group element. Number of valence electrons is 6. 6 plus negative charge is 0. Positive charge is not there. 0 plus number of surrounding monovalent atoms is 2. Total 8 by 2. This is also 4. 4 is equal to also sp3 hybridization. This concept we have to remember first. If you take in the case of geometry, if you observe sp3 geometry of methane molecule is tetrahedral. Here also tetrahedral. This is very important. We have discussed about the geometry, not shape. This is also tetrahedral because it is a sp3 hybridization molecule. Tetrahedral. Geometry is tetrahedral. If you take shape, shape is tetrahedral. In this case, methane molecule. But in this case, shape is pyramidal. This is important concept you have to remember. If you take in this molecule ammonia, the shape we consider as a pyramidal, but geometry is tetrahedral. But in this case, water molecule also V shape or bent. Shape, geometry is tetrahedral, but shape or bent. Shape, this is geometry. Geometry will explain the hybridization. Hybridization concept will explain the geometry. Shape is discussed in case of valence shell electron pair repulsion theory. Hybridization means the number of sigma bonds plus lone pair is considered. In case valence electron pair theory, this is explain the geometry. In case of valence electron pair theory, this is only taken as considered as a sigma bonds of atoms, not considered lone pairs. In case of valence shape theory, it explains the shape of the molecule. This you have to remember. These are the Z is equal to 1 by 2 into number of valence electron on central atom plus negative charge plus minus positive charge, total number of monovalent atoms on the central atom or surrounding atom. If you take three different molecules, you have to find out the hybridization sp3, sp3, sp3. But if you take geometry of this methane molecule is ammonia and water, tetrahedral, tetrahedral, tetrahedral. But if you take in case of shape, tetrahedral, this is pyramidal, this is V shape. Why? Because this is due to lone pairs. This is having one lone pair, this is having two lone pairs. Because of this lone pair repulsions, that's why this molecule is V shape or bent shape, this molecule is pyramidal shape. This is the one of the important points we have to remember. Geometry is always explain about the hybridization. If you consider sigma bonds and also lone pairs. In case of valence electron theory, shape of the molecule is considered as a sigma bond only. It is the arrangement of bonds, atoms around the central atom. Not discuss about the lone pairs. Next, we have to some of the important point. What is geometry? What is shape? This is geometry means arrangement of atoms and lone pairs. Means if you take methane molecule, this is if you take ammonia, if you take oxygen, water, these are some molecule. The bond angle is 109 degrees 28 minutes. The bond angle is 107 in case of ammonia. The bond angle is 104 degrees. These are the bond angles of the molecules. In this case, 1, 2, 3, 4. 4 bond pairs. In this case, 3 bond pairs. In this case, 2 bond pair electrons. This is 109 degrees 28 minutes, 107 degrees, 104 degrees. The arrangement of atoms and lone pairs is considered as a geometry. Geometry of these 3 molecules is tetrahedral. This is, you know. But if you take in case of shape, arrangement of atoms or bond pairs around the central atom. Then it is called as the shape of the orbital or molecule. In case of this molecule is tetrahedral shape. This is pyramidal. This is ammonia. This is methane. If you take water, this is V shape or bent shape. V shape or bent. Because only you have to consider this one only. Why? Because this is lone pair and bond pair. Due to lone pair and bond pair repulsions, these atoms are come closer compared to this 109 degrees. This bond angle decreases. In case of atomic, two lone pairs are there. Due to lone pair occupies more space. This lone pair also occupies more space. That's why this lone pair repulsions are will increase more. Then these two bond pairs will come closer. These two bond pairs will come closer. That's why this bond angle will further decreases. This is called as a, this is known, that's why this shape will, tetrahedral is converted to V shape or bend shape. In case of shape of the molecule, we have to discuss only arrangement of atoms and around the central atom. In case of geometry, we consider all, if you take lone pair also involved in this arrangement of the atoms in the around the central atom. This how to remember, very very important. Next, some of the important point we have to discuss valence electron pair thing. Electron pair always repelling each other. They are try to apart from the molecule. This is one of the point. Second point, different electron pairs are repelling differently. Different electron pairs are repelling differently. They are order lone pair repulsions are greater than lone pair and bond pair, then bond pair repulsions. This you have to remember. Lone pair repulsions are more compared to lone pair and bond pair repulsions. This is also we have to remember. If third one, if lone pairs are zero, then geometry is equal to shape. Geometry is equal to shape. If you take this point, you have to remember, electron or pairs are always repelling each other. They are trying to apart from the molecule. If different electron pairs are there, they are repelling differently because lone pair repulsions are greater compared to lone pair and bond pair. So take in this case, these are the lone pair. This is bond pair. This is also bond pair. These two lone pairs are stronger compared to these two, and also from this bond pair, lone pair, bond pair repulsions, lone pair repulsions. This is the concept of the experiment. If you take Z is equal to 2, planar structure, this is linear, shape is like this. Z is equal to 3. Trigonal planar. This is like this shape. Z is equal to 4. Tetrahedral shape. This is the structure of things. Z is equal to 5. Trigonal bipyramidal by trigonal bipyramidal. This is the structure. Next, if Z is equal to 6, octahedral. This is the octahedral structure. If Z is equal to 7, this is pentagonal bipyramidal shape. This is the shape of the molecule. If it is linear molecule, this is bond angle is 180 degrees. This is also important. If it is the 3 molecule, this is bond angle is 120 degrees. In this case, bond angle is 109 degrees. In this case, having two different of bond angles. This is having 90 degrees. This is having 120 degrees. How many 90 degrees are there? How many 120 degrees are there? Thus, that is also have to remember. Take because 3, 1, 2, 3, 3 120 degrees, 6 90 degrees. 90 degrees. This you have to remember. Because why? With respect to this one, respect to this, this for this for this 3. Like this 90 degrees are 6, 120 degrees are 3. In this case, octahedral, how many have there? This is having 90 degrees because above and below this there, and all are 90 degrees only. This is quite above and below, that's why this is having all 90, total 890 degrees are there. In this case, this is having, in this case, how much, what is the bond angle? This is having 72 degrees, this is having 90 degrees. 572 degrees are there, 5 bonds are there, so 570 degrees, 1 of 5, 10, 90 degrees. Total. How many pentagonal bipyramidal? These are the bond angles of some of the molecule. Z is equal to linear shape means 180 degrees. Z is equal to 3 trigonal planar, bond angle is 120 degrees. Z is equal for tetrahedral 109 degrees. Z is equal to 5 trigonal bipyramidal. This is having 90 degrees with respect to 3 parts. 390 degrees one of the atom. Below the atom also 390 degrees. Total 690 degrees. 3 is 120 degrees. Z is equal to 6 octahedral shape. Octahedral all bonds will having 90 degrees total. It is having 890 degrees. To this, to compare these two, 180 degrees. Linear shape, but that is not taken. All are 90 degrees. If Z is equal to 2 different bond angles, here exists. In all cases, only one single bond angles. Here is inside the bond is 70 degrees, above the plane, below the plane 90 degrees, 572 degrees, then 90 degrees are possible. Different bond angles. If you take, for example, this is the valence electron pair theory. If you take different atoms, different molecules, different, if you consider lone pairs, how the shape, how the geometry of the molecule exists. Next, this is very important in ask in this question also. If you first you take Z, next bond pairs. If you take next lone pair. Next you have to take geometry. Next you have to take shape of the molecule. Next hybridization. If you take another table from based on this, we can first Z is equal to 2. Z is equal to 2. Very, very important. This is put a star mark. So star. Definitely one question will come from this. If it is bond pair is 2 is considered as 2 bond pairs. Lone pair is 0. Geometry is what will happen? Linear shape. If take two different marks A, B. This is linear arrangement. Shape linear. If lone pair is 0, lone pair is not there. That's why geometry is equal to shape. This is also linear. Hybridization 2 means SP hybridization. This is another. If Z is equal to 2, bond pair is 1, lone pair is 1. There is no shape. Only one atom is there. 2 lone pairs. Take one is atom. Two bond pair like this. If you take one linear. If it is A and B, AB, this is lone pair. One is lone pair. One is bond pair. What will happen? Not different shape and both are same because this is a linear shape. Then no change. Any not will be change. Any change in this consider. If you take hybridization also sp3 linear only. If you take for example in case of 3, Z is equal to 3, bond pair is also take 3, lone pair we consider as 0. 3 means geometry is like this, trigonal planar TP, bond angle is 120 degrees, trigonal planar. Means bond pair, lone pair is 0. Means lone pair 0 means shape is equal to geometry. Same as it is like this, trigonal planar, bond angle is 120 degrees. Same trigonal planar, consider no change, any change. The hybridization is 3 means sp2. That you know. If you take in this case 3, take 2 bond pairs, 1 lone pair. 2 bond pairs, 1 lone pair. How what will happen? Means this is molecule, this is having lone pair. In this case, bond angle is 120 degrees. If in case of geometry, if it is trigonal planar only, geometry. If it is in case of, in this case, what will happen? This is V shape or bend shape. In case of, if you take consider shape, this is bond angle is 104 degrees. This is happen in this case of, due to this lone pair, the bond angle will, shape of the molecule will be changed. Hybridization is same sp2 only. Okay, I have to remember this one because this is 120 degrees. Due to this lone pair and this bond pair, this is come up to 120 degrees, it will change to 104 degrees. Bent or V shape. If you take on this case also, we have to consider if you take further, Z is equal to 3, bond pair is 1, lone pair is 2. What will happen? This is one lone pair, this is another lone pair. This is 120 degrees, but in case of geometry, it is trigonal planar only. But in this case, what will happen? This is linear shape because you not consider in shape bond pairs. In this case, hybridization is sp2 only. This is the concept of the linear only. Trigonal planar, there is a structure next. If you take next one more 4, if you take 4, molecule. Bond pairs is considered as 4, lone pair is taken as 0. What is the geometry of this molecule? Take A. This is tetrahedral. This you know, tetrahedral. Means lone pair is 0 means same geometry, tetrahedral only. Hybridization is sp3. If you take in case Z is 4, same bond pair is 3, lone pair is taken as 1. What is the, if you take in this case A is lone pair, what is geometry is same, tetrahedral, but bond angle 109 degrees 28 minutes in tetrahedral. Bond angle is same. Due to this lone pair and bond pair repulsions, it will this close, but this is pyramidal shape like ammonia. The bond angle will come 107 degrees due to this lone pair and bond pair repulsions. Hybridization is sp3, pyramidal shape. If you take 4, this is 2 lone pairs or 2 lone pairs. What will happen in this case? This is one of the lone pair. Take one more lone pair. Like this shape is tetrahedral same. But in this case, A, this is one lone pair, this is another lone pair, this is one bond, this is another bond. What will happen due to bond lone pair repulsions will more, that's why this comes closer. This bond angle is 104 degrees. Hybridization is V shape or bend shape. The hybridization is same sp3. This is the one of the, in case of 4. This you have to note down. Next 4 to 2. Next what will happen? Next should I take 5th one 5. Bond pairs is 5, lone pair is 0. This is the TBP structure. If you take, this is the TBP structure. This bond angle is 90 degrees. Inside the bond angle, this is 120 degrees. Two different types of bond angles are there. This is the TBP structure, trigonal bipyramidal. TBP means trigonal bipyramidal. If it is 5, 5, lone pair is 0. Shape also same, because lone pair is 0. Hybridization is sp3d. In this case, we have to remember very important. If case, one of them, if you take for example PF3Cl2, how the arrangement of the atoms in this case exist. I have to remember important, more electronegative atom occupies equatorial position. More electronegative atom occupies equatorial position. In case of PF3Cl2, this is the equatorial positions, this is the axial positions in case of TBP structure. If how arrangement will happen? First, this is the TBP. You know, more electronegative atom is fluorine. Fluorine is occupies the equatorial position. Later we consider as a chlorines. This is the exact structure of the molecule. If you take in case of xenon trioxide and fluorine, how the arrangement? Which is more electronegative? Fluorine is more electronegative. How the arrangement of the atoms? This is the TBP structure. Xenon is the central atom. How we arrange? More electronegative will occupy the equatorial positions. This is the equatorial position. Later then oxygen and oxygen. Double one. Only. This is the structure of the molecule. Then this is one of the important points you have to remember. In case of Z is equal to 5, bond pairs are 5, lone pairs is 0. In geometry is TBP, trigonal bipyramidal. In this case, two bond angles are exist. One is 90 degrees and is 120 degrees. How many 90 degrees? With respect to 3, with respect to this atom is 3. Total 690 degrees. 3 120 degrees. type of bond angles are exist. After that, if it is not lone pair is considered, geometry is equal to the shape. Say hybridization is sp3d. If in case one of the important concept you have to remember is, if you arrangement of two different surrounding atoms are there, it more electronegative atoms occupy the equatorial position. Means this is the equatorial positions, these are the axial positions. First more electronegativity comes to the equatorial position, later we adjust with the less electronegativity with the remaining positions. This is the one of the important concept in this case, in case of phi. If you take sp3 hybridization, Z is equal to 5, bond pairs are 4, one is the lone pair. What is the structure of this molecule? How it is exist? This is the lone pair. This is in this case. Geometry is TPP, trigonal pair. This is also included in case of geometry hybridization. But this is actual shape is seesaw structure. It's like this. If you put this one, this is lone pair. Like this. This is a seesaw structure. Seesaw. Next hybridization is sp3d. In case of that, if you take 5, 3, 2 lone pairs are existent. What is happen? What will happen? This is case 1 lone pair. This is another lone pair. A, one bond pair, mark pair. Next, if you take 2 lone pair, take 2 lone pair. So geometry is same, but this shape is T shape. Hybridization is sp3d only. This is one of the important how to remember. If you take in case of 5, bond pair is 2, lone pairs are 3. If you take, these are the 2 lone pairs, this is also take as a lone pair. Geometry is same, TPP only, not will change, but in case of this one, it is a linear. This is a linear. Hybridization is same. No problem. These, if we, with examples, you have to remember some of the examples. Then only we can understand this easily. Which molecule will show the one of the concept, lone pair always placed with the axial position only. Lone pair occupies axial positions. Lone pair occupies always axial position only. Then only this. Next, if you take in case of take 6, bond pairs are 6, lone pair 0, geometry is octahedral. This yeah. This is octahedral. Geometry is equal to shape same. Hybridization is sp3d2. Because due to octahedral, this is sp3d2 only. Bond angle is 90 degrees. All bond angles are same. This is total. How many? How many bond angles are there? Total 690 degrees. So, means 1, 2, 3, 4, 5, 6. All are equal ones. This is the octahedral. Only single bond angle exists 90 degrees. This is octahedral. Hybridization is sp3. This is one only. Next 6, 5, 1 lone pair exists. 5 bond pairs, 1 lone pair. Bonding all are same, but in case of hybrid, in this case, shape is considered. What will happen? Shape is considered. What will happen? This is the square. This is the square. Means this is planar. Plane, another plane. This structure is, shape is square planar. In case of 5 bond pairs, 1 lone pair is there. This shape is considered as a square planar. Geometry is always octahedral. Hybridization is same, sp3 d2 only. In case of 6, 4, 2 are there. This is also taken as a lone pair. This is also lone pair. This is also lone pair. Okay. So this is square only. Square planar. Square pyramidal. This is square planar. This is square. This is like a pyramid. Square pyramid. Small correction. This is square pyramid. This is square planar. Because only planar, this is square pyramid in this case. In case of 1 lone pair, in case of 2 lone pairs, hybridization is same, sp3d2. This is small correction. This is square planar. This is like a pyramid. That's why this is square pyramid structure. In this case, square planar only. This is pyramid. If in case of last one, 7, 0, what is the structure of the organ? The bond angle is 72 degrees and 90 degrees. Between this is 70 degrees. With respect to this 90 degrees. Total how many? With respect to 5. With respect to this bond 5. With respect to this one, total 90 degrees. Next to 72 degrees means 1, 2, 3, 4, 5. 5, 72 degrees. This is pentagonal by pyramidal. Pentagonal by pyramidal. This is pentagonal by pyramidal structure. This is in between these two 72 degrees. Total 5 bonds are there. 1, 2, 3, 4, 5. That's why 572 degrees. With respect to 90 degrees, with respect to this inside the atom with the outer atom, outer bond pair with the inter bond pair. 90 degrees with respect to this 5, with respect to this 5. Total 90 degrees, 572 degrees. This is pentagonal by pyramid structure. Shape, in case of lone pair 0, shape is equal to geometry same. Hybridization is sp3d3. Hybridization is sp3d3. This is up to this. Now to remember, this is the valence electron pair repulsion theory. Main explain about the valence electron pair, about the shape of the molecule. How, if you not consider in case lone pair. In case of geometry, we consider lone pair plus bond pairs. With the two different molecule, geometry is equal to shape. When lone pair is equal to 0, then shape is always equal to the geometry. With the 2, 4, 3, 4, 5, 5 different bond pairs, different lone pairs, changing different atoms. We discussed about the hybridization. What is the shape of the molecule? What is the geometry? If lone pair will change, how the geometry will change, how shape will be changed. This is the about the valence shell electron pair repulsion theory. Yes, thank you.